Alright, for my Kickstarter campaign, I've been asked to create a movie demoing my prototype. It's more of a product at this point than a prototype because it indeed functions. This is the front side, top side of the Unidriver. I'm actually holding it upside down. What the Unidriver allows you to do is tackle one of the major problems that all microcontroller boards that I've seen or experienced have in common. Raspberry Pi, the Asus Tinkerboard, Arduino, Teensy, Nano, you name it. What these all have in common is they cannot drive large current loads. With this board, even if you don't know the requirements of your load at the time, you can drive any load. U1 is a 6-pin, it has 6 pins, opto isolator. Let's see, sorry. This camera is really something else. Q2 is an NPN transistor, and MOSFET 1 is a MOSFET. So what I've done with this is I've made a universal board, this board, which can be used to reconfigure any one of those three devices to change how it drives. Do you want an opto-isolated MOSFET? Fill in U1 and MOSFET 1, and that channel is now an opto-isolated MOSFET. You know, with various passive components that go in the slots, the 2-pin slots. What's great about this board is it comes with 4 channels, so you can configure each one the same or different. And this here is the back. I have currently in the documentation 12 modes of operation for this one single board. It can operate as a MOSFET driven high current output, just an NPN transistor if you wanted to do that, or a direct driven MOSFET, or a transistor driven MOSFET, or an opto isolated MOSFET. You can trigger, if you use 4N35 for the opto isolator, you can actually trigger the load side as well, because the 4N35 works as a regular NPN transistor. We have a mode for that. Let's see, other important pieces. The great thing about this is if you assemble it with headers, male or female. I like the male ones because I have all the equipment to do DuPont, so I can create DuPont jumpers. You can actually prototype out your high side, or well, your load driver. You can prototype out your load driver from trying different resistors to trying out different LEDs if you want to do that, or what resistor your LED has, multiple voltages. You can figure it out as you go. Another great thing about the design is if you like eBay, like I like eBay, because I like that bargain bin China stuff, and you got a little bit of skill. I can't get it to focus really well, but let's see. You can actually use the cheap 4-pin opto isolator, it's in there, instead of a 4N35 for a little bit of a cheaper option, and still get opto isolation all the way across the board. You just don't get the 3rd pin where you can actually drive the high side of the opto isolator. These are the signal indication LEDs. These are the load active LEDs. You can see on this side, these are your loads. You got ground, your switching, and your voltage, so you can supply ground, or you can supply ground or power and switch it on either side. That's actually under further development, because in version 2, which is what my Kickstarter is about, I'm going to change the design so that you can drive high side and low side components, which would essentially turn this singular board into a multi-configurable H-bridge. If I were to design this as a prototype, like to start from scratch, and you turn these into female headers instead of male headers, it would basically turn it into what you have with an Arduino. You'd have the female headers. You could just plug resistors across these 2 pins. In all the documentation, I tell you how to configure the different drive modes. I've tested every one of the 12 drive modes I currently have for this, including a coil driver and a few others. There's spots on the board where you can put flyback diodes as well to run inductive loads. It's just very, very, very versatile. If you can think of a driving mode for any system, any load larger than 50 milliamps, I think that's Arduino, or 500 milliamps, which is your basic NPN, this will even do it. The MOSFETs I've populated it with can do 55 volts at 40 amps or something like that. So, I mean, and that's why the board is traced out so wide. I use some pretty wide spaces in the artwork, or wide traces in the artwork, so you can handle decent loads. I'm not saying that it'll do every bit of that, by no means, but it will power bigger loads. As an example of this, I actually have this one here. This is actually running. So this one, it's hard to see because of the wires. I didn't have any smaller wires. This one's populated with 435. It's a static configuration. It's completely configured all the way from the beginning to the end. I plugged the resistors in, figured out the values and all that. And this one actually runs this pump that's in here. So basically, since I'm using this as an opto-isolated MOSFET driver, what you end up with is all your powering is the LED, which is, I mean, Arduinos can drive LEDs non-stop, days in, days out. When we pull this wire right here from 5 volts, the pump stops, the lights go out. When we get 5 volts again, our driver lights come back on, the pump starts flowing. I've done plugged it up. I really wish they would allow editing, because that was really a lot just to plug it in. I don't have currently, without doing a stop shot either, a configuration that's plugged into Arduino, but I do know for a fact that's what I had designed this for, is Arduino. I also have the designs for 3D printed case that allow it to be 100 millimeters by 100 millimeters, just simple case. Also, if you populate the LEDs on the bottom side of the PCB, it will allow you to actually mount it to a wall, and all you'll see is the indication of what's being driven and what's not. The lid also has a 40 millimeter fan grate to allow you to cool your MOSFETs, push air in and push it out. This is one I built so that you can experiment with it. You can change the jumpers and stuff. Like I say, I have the DuPont set up, so it's really easy to make DuPont resistor jumpers and such. You can use hard drive shunts to create hard wires, etc. But if you did it in a female configuration, it would be just as easy to configure. It also is enabled to use dual voltage source, 5 volts and 12 volts, or 5 volts and high voltage. So you have a low side voltage and a high side voltage in case you want to do like an NPN transistor switcher or anything like that. And then, I wish this was focused better, but this right here is called POWERJUMPER. If you wanted to run it off one single supply, every component on the board, then you just put 2 jumpers, 2 shunts here, and then now it's a single supply board instead of a dual supply board. The great thing about this is you can pick your components as you go across. As long as this is an N-channel MOSFET, as long as this is an NPN transistor, and as long as that is some sort of opto-isolator that has anode on top, cathode on bottom, collector on top, emitter on bottom, you can change whatever component you got. The board allows you to be versatile with it. Change your LED colors, change your LED resistors, just run with it. I meant to make a short video. I'm coming in around under 10 minutes. So that's about it. I welcome any questions and comments. Let me know. The Kickstarter page link will be in the lower comments section. Alrighty, y'all. Have a good day. Bye-bye.